Hello everyone, welcome back to our channel. This is Om and today we are gonna discuss One Way Slab part 2. So if you haven't seen my previous video, you need to watch that because it's the second part, so you first need to watch the first part. Now the question is what we have discussed in our first part. So let's recall that. So we have already discussed one-way slab, two-way slab. Then what is the difference between these two slabs? Why is the difference between these two slabs? Then we have learned how to calculate effective depth, overall depth, then effective longer span, effective shorter span, and let me just sneak into my notes. Yeah, so apart from all this, we have also learned how to read the codal provisions. Now today we will learn how to calculate the loads, then moment, and then we will learn how to calculate the main reinforcement, distributors, and the spacing between the main reinforcement and distributors. So I am already with my pen, notebook and my calci. So pause the video, take your time and come to the class after that once you have all these things. So just go get your notebook because I am going to teach you very important points. So let's get started. So one-way slab. Let me explain you the question again. So we had a slab of 9 meter by 18.2 meter, which we have divided in 5 equal parts. You can see it here. The beams were of 300 mm and the support were of 230 mm. The support was a masonry wall. Also, the important point is the live load was 4 kN per meter square. Then the dead load due to floor finish and partition was 1.5 kN per meter square. Grade of steel was Fe 415 and we don't need the rest now. So we have already calculated the aspect ratio through which we knew that it's a one-way slab. Then using the code we came to this formula and we have calculated effective depth from here. So after that we knew that effective depth should be more than 105.6 mm, and then we had calculated the overall depth, and finally we decided one effective depth. After that we calculated the effective span. For that we had to choose between these two conditions and we concluded our shorter effective span as 3514 mm and our longer effective span as 9230 mm. To know in detail you have to watch the previous video. Link is in the description, so you can go there. Without having the proper knowledge of the previous video, you can't understand this one. So now what we need to do is to calculate the loads on slab. So our new step will be step 5. Step 5, which is calculate loads on slab. So what are the various kinds of loads? First is dead load and second is live load. So what is dead load comprises of? Dead load is comprises of self weight and the load of finishes and partitions. So we will calculate the self weight of slab. Self weight of slab. How we can know the self weight of slab? So we will just multiply the unit weight of concrete, which is 25 kN per meter cube, with the thickness of the slab. Now what is the thickness of the slab over here? It's the overall depth. So we need to check the overall depth now. So it's 150 mm. So I will change the unit in meters and then I will write it as 0.15 meter. So let's calculate it. It's 25 into 0.15, 3.75 kilonewton per meter square. Now you can comment down what is the unit weight of the concrete. Okay, now in our question it was given that the loads of finishes and partition is 1.5 kilonewton per meter square. So I will just write it here. Load of floor finish and partition. Floor finish and partition was 1.5 kilonewton per meter square. You can see it, it's here. Then I can calculate the dead load. So dead load is equal to the addition of these two, that is 3.75 plus 1.5. So I will just add it. It's 5.25 kilonewton per meter square. Then we need to calculate the factored dead load. Now what is factored dead load? When we will multiply the dead load, which is 5.25, with factor of safety, which is 1.5, then we will get factored dead load. So answer multiplied by 1.5, 7875. So 7.875 kilonewton per meter square is our factored dead load. We will symbolize it as WDL. Now we need to write our live load. So our live load was given in question. You can see it here. Where is it? Yeah, live load 4 kilonewton per meter square. So it's 4 kilonewton per meter square. Then we need to calculate factored live load, which is live load into factor of safety, that is 6 kilonewton per meter square. You can symbolize it as WLL is equal to 6 kilonewton per meter square. Okay. So we have calculated loads on slab. Now we need to calculate moments. So step 6 will be calculation of moments. So for that I will show you the figure. See, here we have a figure. In this you can see that we have different moments at supports and at the center of the slab. So this is a support which can be considered as simply supported, this is a continuous support, and this is the center of the slab. So we have different moments over here. So we will calculate it first. So let me write it for you. So at the supports we have negative moments and in the center we have positive moments. So I will calculate accordingly, and then we will design our slab according to the maximum moment. So first of all we need to calculate it at the end support. So it's WUDL plus WULL divided by 24, and then whole unit will be multiplied by square of effective shorter span. So you can name it as A. Then what's our WUDL? It's our factored dead load. So 7.875, then factored live load, which is 6 divided by 24 and multiplied by our shorter effective span. So what is our shorter effective span? We need to check it. So our shorter effective span is 3.514. So I will just write 3.514, the square of this. Now I will calculate it. So answer plus 6, answer divided by 24, 0.578, we can write it as 0.58, then 3.514 square, 12.348, so we can write it as 12.35. Then we have the negative sign here showing that the moment at supports is negative. Now I will just multiply this to 0.58 into 12.35. It's 7.163. So it's minus 7.163 kilonewton meter per meter. So it's the unit of moment. Just remember it. Then we need to calculate our moment at the center of the slab. So for that we have formula of WUDL by 12 plus WULL divided by 10 and whole multiplied by L square. So WUDL is 7.875 divided by 12 plus 6 divided by 10, then L square was 3.514, and this moment was a positive moment, so it's a positive, so we don't need to write the sign over here. Okay, now we will calculate it. So 7.875 divided by 12 is 0.656. We can write it as 0.66 plus this will be equal to 0.6, and then we have 12.35 because we have already calculated it in our previous numerical, so I know the value. You can see it here. Here we have calculated it, so I will take it as 12.35 in the further numericals. It will save my time. 0.66 plus 0.6, which is equal to 1.26 into 12.35, which is equal to 15.56 kilonewton per meter cube. And then we have to calculate another moment which is at continuous support, and the formula for that is WUDL divided by 10 plus WULL divided by 9. Once you do 4 to 5 numericals, you will remember the values like the formula, so don't worry about that. These are not very complex. All you need to do is to practice a lot. So it's 7.875 divided by 10, then 6 by 9 into 3.514 and the square of it. Then it will be 0.7875 plus this will be 0.67. You can divide it. I already know the value, 12.35. Then I need to add it, 0.7875 plus 0.67, which will be equal to 1.4575. I can write it as 1.46, 12.35, 1.46 into 12.35, 18.031, 18.03 kilonewton per meter. Sorry, it will be kilonewton meter per meter. Okay, I'm sorry, I have written wrong unit here. It should be kilonewton meter per meter because we are dealing with moment. Meter per meter. So now that we have calculated all our moments, like the moment at the support, this was our first support, this was our second support, and this was our third support. So we will design our slab for the maximum moment. So I can write which is the maximum one. It will be negative in sign, so you can write negative here because it's the moment at support. Now, which is the maximum one? And maximum should not be according to the sign, but it should be according to the numerical value. So it's 7.163 here, 15.56 here, and 18.03 here. So I can write that maximum moment is equal to minus 18.03 kilonewton per meter. Sorry, kilonewton meter per meter. Okay. Now we will design our slab for this moment in the next class. Apart from that, I will show you how to calculate the main reinforcement, how to calculate the distributors and the spacing between them. And in the upcoming videos, I will explain you the drawing of the slab. Till then, thank you and have a nice day.